Okay, so I want to give you guys some example problems where you might need to use the z-score table. Um, this one is find the probability for a normally distributed data that, okay, so the question is, what is the probability that your z, if you randomly pick one, will be between 0 and 1.81? Okay, so all we're going to do on this is look up in the z-score table a z-score of 1.81 and then figure out what is the probability that my z, if I randomly pick a z-score, that it's between 0 and 1.81. Okay, that's what this notation means right here. So really all we need to do is look up a z-score of 1.81. So if we look up here, so all right, 1.8, this is 1.80, this is 1.81 right here. So that would be 46.49%. And remember, these are decimals, and if you want a percent and you have a decimal, then just move the decimal over a couple places to your right. So that'll be 46.49%. So 46.49% for that one. Okay, what about this one? What is the probability that your z is greater than negative 1.21? Okay, so this one's slightly trickier, so be really careful on this one when you do this one, because you don't want to just use the z-score value for what was it, 1.21? Okay, so we're going to use 1.21, so let's find that. So here's 1.2. Here's 1.21. Okay, so 38.69% of the data, that is the amount of data that falls in between negative 1.21 z-score and the mean. Okay, and I already forgot what I said, 38.69%. Okay, so there's 38.69% here. The question is, what's the probability that you find something greater than a value right here? So it's 38.69 plus the 50% chance that you are above the mean. Okay, so altogether that would be this plus 50% or plus 0.5. So it should be 88.69%. Okay, so that would be 88.69%. Okay, so that's those two. Now you do get some really good questions like this, and these are actually people actually look at data like this and figure, okay, so if the speeds of cars is normally distributed, which I'm going to just go out on a limb and say that that's probably not unreasonable to think that the speeds of cars on highways is normally distributed. It follows a bell curve. It's probably not exactly normally distributed, but it might be. I don't know. Anyway, the speed limit on I-75 around Findlay, Ohio is 70 miles an hour. On a clear day with no construction, the mean speed of cars was measured at 62 miles per hour with a standard deviation of 6 miles per hour. If the speeds are normally distributed, what percentage of the automobiles are exceeding the speed limit? Okay, so really you have to ask yourself, okay, let's look at our normal distribution drawing here. Okay, so we've got the mean is 62. So the mean is right in the middle. That's 62. To be speeding, you have to be going more than 70. Okay? So 70 is going to be floating somewhere over here. Let's just say that we draw our 70 right here. Okay? Let's say 70 is right here. The question is, how many standard deviations away are you? So you need to find your z-score first. So, and we did this yesterday. All you do is figure out how far away is your speed from the mean. Okay, so 70 minus 62 is 8. Okay, so you're 8 miles an hour above. And the question is, how many standard deviations is that? Well, if you just do 8 divided by 6, that will tell you. So you are, if you do that, you'll get 1.333 repeating. Okay. And so on z-scores, generally we round to the hundredths place or the second decimal. So what this tells me is that I have a positive z-score of a positive 1.33. Okay. The question is, what percentage of data is above that, right? Because to be exceeding the speed limit, you have to be above this line right here. This is 70 miles an hour. So let's find the percentage here in the yellow. Okay. and then we will add 50% to that. So that'll give us everything below 70. Okay. That'll probably give us a pretty high percentage. And then what we'll do is we'll take 100% minus that, and that'll give us this little tail here, this little white tail. Okay. So a z-score of 1.33 gives us, okay, so here's the table, 1.33. Okay, so what that tells me here is that 40.82%, so 40.82% is this yellow area. So if we add 50% to that, so what did I say again? 40.82%. Okay, so 40.82% plus the 50% to the left of the mean gives us 90.82%. Okay, and that's the people that are below the speed limit. Okay, so if you want to know the number of people above the speed limit, just do 100% minus 90.82. Okay, oops, sorry. So 100% minus 90.82%. That will give us, let's see, 9.18%. Okay, so the probability that you just find a random car that drives by that's speeding, given this information, is 9.18%. All right, so that's how you do those. I hope that helps, and best of luck on the homework. Hopefully I'll see some of you at Metrothon. If not, I'll see you Monday.